It's just setting it up. So the internet tells me. All right, I think we should be live on YouTube. And so good evening, everyone. My name is Allendria Brunjes. I'm the editor-in-chief of SkyNews magazine, Canada's astronomy and space magazine. With me tonight, I have, as per usual, Paul Owen, the magnanimous, amazing Paul Owen, who is our astrophotographer instructor of the night. He will be showing us how to edit data from which globular cluster did you choose tonight? Was it M13?
M13, yeah.
M13. So this month we had a surprise of two sets of data, M3, Messier 3 and Messier 13, both globular clusters. And so a lot of the editing techniques would be the same because they're the same type of object and they look very similar. You would do the same things to edit the image. And so, Paul, you said that you had some words of discussion about these globular clusters and what they are, and what is it that we're looking at behind me here?
Okay, so I want to find a correct description, and so I went to the NASA site, and of course they have an absolutely stunning Hubble infrared version of this, of course. But anyway, what M13 is, of course, is it's a globular cluster, and there's two different types of clusters out there. There's the open clusters, which are just a few stars but grouped together. Then there's the globular clusters like you see behind both of us, and they are basically gravitationally drawn together. And the globs have many stars in them. There's some inaccurate, no, I won't say inaccurate. Let's just say many people think different numbers for the amount of stars that are in these clusters, especially M13. The more common number you'll hear is over 300,000. The one that NASA says over 100,000. So whatever number it is, it will be correct because it is over 100,000. And some people even say close to 500,000. So however many stars that are in that, we can only see it from our perspective. We can only assume that in behind there's even more that we don't even see. So so it's just an amazing thing to behold. The neat thing with these clusters too, actually, I'll just tell you about this particular one, is and I'm just going to read this 2 short paragraphs. So like shiny flakes sparkling in a snow globe, and that's exactly what they look like, over 100,000 stars whirl within the globular cluster M13, one of the brightest star clusters visible from the northern hemisphere. And it's 25,000 light years from Earth. So we're seeing this light 25,000 light years ago, and because we're looking in the past, which is really cool. So from Earth, an apparent magnitude of 5.8, this glittering metropolis of stars in the constellation Hercules can be spotted with a pair of binoculars most easily in July. And if you are actually in a really dark sky site, and if you've got a relatively good vision, you can actually see it naked eye.
Oh, really?
Yep, it'll look like a star, but it'll look like a smuttery kind of a star. And but you can see it naked eye. So the English astronomer Edmund Halley, best known for recognizing the periodically of the comet that bears his name, he was the one that discovered M13. And he discovered it 50 years before Charles Messier cataloged it. And when Charles Messier cataloged it, he cataloged it as a nebula because he thought there was no, it was just a solid structure. And it wasn't until 1779 that they had enough magnitude or enough magnification to actually resolve it to see that it in fact was globs of stars. So yeah, so it's pretty interesting that it wasn't Mr. Messier. He actually cataloged it, but it was actually our Halley guy on the comet that actually discovered this this globular cluster. Isn't that interesting?
Yeah, it is. I've always found globular clusters like when I go stargazing with people, I try to point one of them out. And usually one of the lines I say is, that's probably the oldest thing you'll ever see in your life. Because they're some of the oldest groupings of stars in our galaxy. I think there are about 150 floating around the Milky Way. And I read, I think it was on NASA's site, that they would have been around at the formation of the Milky Way. And so they're, so these stars are like, for the most part, they're very slow burning. Some of them are kind of like red dwarfy, you know, sci-fi that I've read, and some things that I've read about them is like, you know, because they're so old, it might be more likely to harbor life. But there's also like this idea that, you know, I mean, little blue stars, right? And so they're finding that little blue stars are forming because stars are kind of crashing into each other.
Yeah.
Like these are very dense. Like this is, you know, our star is fairly lonely out here, with the closest one being.
Our star is a sun, of course, from us. And
the closest star besides the sun.
Oh, the
Centauri.
Centauri. Yeah.
And so that's, you know, a fair distance away. Whereas if you're in the center of here, you're going to have many more neighbors.
Oh, imagine how bright that would be.
Yep.
See no night. That is. No, it's what you said about that's true. Because I was reading in the same article about that's what happens is these stars are so closely clumped together that they're continually banging into each other, and they're actually forming new stars.
Yep. And it's because I was having a discussion with I think it was the Robotic Telescope team about why there would be so many blue stars in Globular Cluster if it's so old, because blue stars tend to be, you know, young and hot stars that are you know, burning fast and bright and burn out really quickly. And yeah, it's because the stars, when they crash into each other, they kind of start to turn blue, burn differently. So
yeah, it's amazing. And you know, for when and we'll get into this a little bit when we do the processing of it. But I remember when I first started looking at these clusters and started to take pictures of them. And of course, you just use a DSLR and you get a picture and you think, oh, you know. And it's so easy to think that all these are just white. But when you actually resolve it and can preserve the color in these stars, there are like so many yellow and blue stars mixed amongst us, and you'll see that when we go through it. That is just amazing to me, you know, to see. And you were going to mention my little nerd hat would have on it
propeller. The
That's
propeller
right.
is sitting right on it. Yeah, and so
this is right now. Sideways like a windmill, but
yeah, it's kind of hard to catch. And you know, I was playing around with this data too, and the M3 data that we have, and I found it's much harder than I thought, because it's only the three. We've got the red, green, blue, and we don't have luminance, because for a globular cluster, it's not really that necessary. But it's so hard to like make it so that you can see it. And so like this propeller, from what I've read, is like one of the indicators that you're doing a good job, right? See the propeller, which also I've been reading a little bit about this online, and some people are talking about how it's dust clouds. But anybody who's watching us tonight, if you you can also talk in the chat on YouTube there. If you have any more information about this propeller, by all means share it with us. But yeah, it's part of the cluster, and there's an astronomy.com, I think it was astronomy.com had an article about how it's seen differently by different people, or at least in their observations. And so like it's a really interesting feature. I'm not able to catch it myself in Photoshop. So maybe tonight's lesson will teach me a little bit more about how to edit the photos, and I'll be able to isolate the propeller.
It's hard to do, because if you do that, then you're kind of taken away from something else. So it's a real balance to try to get the right amount of, it's just an exposure thing. And just to get it to kind of stand out. Right about where it is now is about as bright as or as dark as I would put it,
Mhm.
without compromising anything else around it. But once you see it, you can't unsee it, because it's just one of those things. Once you find it, you know how you take those pictures that were just nothing but fuzz, and you
Mhm.
stare at them with averted vision, and all of a sudden the picture pops out at you.
Yep.
And it's kind of like that.
Yeah. Actually, it took me a while to find it, even in the photo that you sent me. This one, like I could not, like I had to go and find somebody else's like very obvious observation drawing where they drew it very darkly.
Yeah.
I said, okay, so this is where it's supposed to be, and these are these two stars here. This is how I kind of narrowed it down. I'm like, stars here, propeller there, other star over here. Okay, this is where it's supposed to. Oh, there it is. Okay. Yeah.
It's funny. I didn't know anything about it either. And then at one point in time, somebody commented on somebody else's image and says, "Oh, you got the propeller." And I was saying, thing, the propeller, what's that? And so I started to dig into it, and sure enough, there it is. So if you're ever shooting this one, and if you can get the resolution where it's big enough, the propeller, even that little image I sent you of my own, the propeller was on it. So, but you got to look a little harder on that one. But this data is really good to see it.
Yeah.
Yeah.
So.
All right. Well,
all right. So the data. The data.
Yeah. Oh, and by the way, if you want to find this target with a pair of binoculars, because we're now getting into our summer constellations. As soon as you see Lyra up in the sky, and that will be Vega, it's a very, very bright star coming up in the northeast this time of the year, and you'll probably start to see that somewhere's 10:30. It should be up clear enough. Anyway, Vega is just above Cygnus the Swan. And so Cygnus the Swan would be here, Vega would be there, and then right up above Vega, you're going to see the great square of Hercules, the actual Hercules constellation. And in that constellation, in the square, M13 sits on one of the lines between two of the stars. So it's really not that hard to find. Once you know where Cygnus and Lyra are, and you know where the constellation Hercules is, it's in the square of Hercules. And it's almost 1/3 the distance between two stars. So when you find one star, just look 1/3 one way. If not, look 1/3 to the other. You've only got 4 lines. It's one one's on top. It's easy to find.
And it is a little easier to see in light polluted skies too. Like I've had to find it in the city. It's a little bit like, you know, touch and go, but like, so if you have binoculars or a telescope, I have my little 80 mil refractor, and I can find the Hercules cluster with it. Like it's if it's a hazy night, it's usually a no-go. But if it's clear and I'm in maybe a park in the city, and you know, people's eyes are well adjusted, then I can usually point it out.
Perfect. Yeah, it's good that you can see from the city, because there's not much you can see from the city.
No,
this kind of stuff. So that's wonderful. You can see that.
Like usually it's a little bit harder to see, but like, and you know, I'm not saying sit underneath a street light and point directly at it or anything, but you know, if you're like, also in Collingwood, like when I was in Collingwood, I had lights all around me and I could see the Hercules cluster from Collingwood, like in my backyard. So, or like in the kind of like outer regions of Toronto where it's still bright and you're like, the orange, but you can still, like, it's doable.
Yeah.
That's important. It's an actual doable thing.
Yeah, it's once you know where it is in the sky anyway. It's when we do our star parties, it's one of the objects that we immediately go to. You know, it's just one of those things that's real popular. So
yeah.
All right. Well, then I guess we should start with our data.
Awesome.
Now let me see if I can share my screen. I have to be actually full size, I think, to do that. There we go. Share screen, and it should be. Let me see. Is that the one?
And for anybody who's watching, I just shared the link in the chat on the YouTube page. So if you're looking for this data, you can download it for free. And once you've edited it, you can send it in to us for the Astro Image Editing Contest, where you can win a SkyNews prize pack, which includes a little fold-out chair and a backpack, and 1 year of RASC Robotic Telescope data for free.
Wow, that's a great prize.
Mhm.
Maybe I should enter. I like the data.
I like the way you edited this image. So,
Can you see my screen?
yep.
And so you're looking at the cluster?
Yep.
Okay, so this is the one I did today. And I'll actually go out of it a little bit. Whoops, the other way. There we go. So, so this is what we're going to sort of end up with, I think. But what we were talking about in this cluster, if I back it out, you can see the propeller a little better. Can you see my mouse?
I can see your cursor. Yeah.
Yeah, so, or my cursor, yeah. So you can see there's one propeller. It looks like the blade from a windmill. One there, one there. I'll show you like on another image later. I was more concerned about the cluster on this one, so I was bringing that up. But you can see that there's a very dark lane here, very dark one there, and very dark one there. So that's the three blades of the propeller right there. But you can see, besides the propeller, all those blue stars we were talking about, and all those yellow stars, which are like our sun, and there's some various ones in there, but they are so jam-packed together. It is unbelievable. And besides that, we have a little friend. See if I can find him. Where is he? There he is. Right there.
How about that?
Our little galaxy buddy right there. He's
Nice.
just there. And apparently this is associated with virtually hundreds of galaxies in this thing, but we can only see certain ones, but in any event. So this is what we're going to be working with today. So let's go to this screen right here. And this is the one that I was working today. Now, with this particular target, it's quite different than doing nebulas because it's bright to begin with. And you can, depending on how you process this, some people do actually use luminance on this, and I did on this one, and some people don't, but it all depends on how you stretch it. And stretching it is the part where we go from linear to nonlinear, when we're taking it out of its, basically, its black stage, and we're starting to pull the data so you can see it more. Once you go into that stage, that's where you can either make or break the preservation of the color of the stars. And so in some instances, when you do this, if you approach it the right way, you're going to be gently bringing out the detail and the color in the stars to the point where the image looks almost a little flat and lifeless. So in that case, that's where you might want to take a luminance image and put it on top just to create the brightness. Not so much that you're going to get any more detail, because again, it's stars. So, it's not like we're trying to bring up fuzzy details in a nebula or anything like that. The only reason for the luminous is just to add some pop and brightness and vibrance to it. And you'll see what I mean by that as we go through it. Now, this particular image, how this happened to be was, I'm going to show you the history of what actually took place to make this image. So all of these things that you see here are things that we did to the image to bring it to its final state. And it's an initial state right here is where we actually start working prior to the initial state. In the initial state, that's where we will combine the red, the green, and the blue data. That's where we'll do our background neutralization or our dynamic background extraction. That's where we'll do our color calibration. And that's where, if in fact we want to extract luminance for brightness, not for detail, that's where we will do it as well. After we've done all that, then we're going to put those two, the luminous image together with the RGB image to make an image that that will be in nonlinear form. And from there, it actually goes quite easy, because this type of a target is not a hard target to do on the back end. And what I mean by the back end is after we've gone from linear to nonlinear. From that point on, it's really just artistic stuff and brightness and maybe star shaping and, fixing background, just very simple things. But putting it together prior to that is the importance of this particular target that I found. And I've done it a number of ways, and I wanted to do it a whole bunch of different ways to find out what was the best way to approach this particular data set if you're going to, in fact, take this target on. So, so let's start at the beginning. So what I'm going to do, I'm just going to tuck this image aside. And you'll see that I've got a bunch of other things kicking around that I used from before. And I may use some of them just to save some time. I'll explain them, but I may just use them just to save some time. So the first thing that we need to do with this data, and I want to actually see if I can find it first. I want to point something out. If you're using PixInsight, which is our software choice for this particular series, I want to show you there is a process in here called blink. And this is rather important, and I'm going to show you why. So if I'm going to look at the data, so let's open up the files. Oops, it's not going to work for me today. There we go. M13, we're going to go to masters. Or not masters, sorry. Whoa, M13.
Nope. Lower center, second from the bottom. Okay.
Yeah, I just got to make sure I get the right one that I did. I think it was in this one. And then if I go to registered, there we are. Okay. So I'm going to open up, just say, for example, just the blue files. And I want to put them in blank. And the reason I want to do, I want to do that is because I want to show you something on this specific data that's quite important to know. All this is going to do is just load the blue data set in here so we can look at it. This is something that you should do in your workflow anyway. Before you start processing your data, have a look at your subs, because there could be something in there in a sub or two that maybe you may not want in there. This is what I found in this particular data set, not to surprise anybody if they're going to do this. And if they're going to do it rather than just taking the master lights, there's a way you can mitigate some of the reflections that were in this particular data. So if you look at the first image, and I want you to pay attention to this corner of the image, I'm just going to run through each particular picture. And you're going to find right up until the last two, it actually looks pretty darn good. But the last two, guess what happens? Bang. We've got this major reflection in the last two images. And that's the same in the red data, the blue data, and the green data. So there's a way you can take that out, and I'm going to show it to you down the road. Or when you stack this, if you're going to do it like you actually stack it yourself, you can just leave those two off the blue, the two off the green, and the two off the red out. And you won't, this will actually be far in the background, so you won't see it as much. Although stacking will take care of some of it. So anyway, I just want to point that out. So just not to surprise anybody when they see it.
Yeah.
Okay, so let's go ahead and let's open up their data. So we're going to open our master files. So we'll go back to M13. Oops. I'm in the wrong place, that's why. And M13, there we go. And I'm going to go to my master files, and these bottom three are our red, green, and blue. So that's what you're going to do. If you're going to go to your masters, you're just going to grab those three files and we'll open them. And they should pop right up for us. And there they are. So we have our red, our green, and our blue master lights. And this one here is the blue and the red and the green. What I would do sometime with this, and I experimented with this today too, is sometimes I would do a linear fit right from the get-go and equalize the exposure of each of these images equally so that you would have a proper mix of color. But you don't necessarily have to do that. You can do what we've kind of been doing all along and get the same result. So the first thing that we're going to do with this is we're going to go ahead and we're going to combine the channels. So we're going to open up channel combination. So if you go to process, all processes, everything's in alphabetical order, down to channel combination, and just click on it, it'll open up. I just happen to have it in my tools over here. So make sure that you are, the RGB is the one that's highlighted. That's the default one. So you should be no problem that way. You go over to the side tab of your file, and you look for what color it is. In this case, it's red. So you just simply grab it, drop, and drag it into the R for red. We're going to go ahead and do the same for the blue. Drop that into B for blue. And we're going to go ahead and do the same for green. Drop and drag into our green. So now that we've got those in the channel combination, I am just going to move these ones out of the way. I'm probably going to actually delete them because we really don't need them now. And we're just going to open this up. And now we have our RGB image.
Okay.
So I am going to take and delete these ones now because I want to try to declutter as much as I can on this, because I'm starting out with a bunch of stuff on it when I normally wouldn't have any. So we have our image now. So when you go ahead to open this, the first thing that you're going to do, because you need to see it, is you want it to do STF, a stretch on it. And it's not a permanent stretch, it's just the ability to see what's actually in the data without stretching it. And when you do that, you use this STF screen transfer function. And it's a really simple thing to use, of course. What I'm going to recommend that you do is unlink the chain. When you unlink the chain, then screen transfer function is going to look at all three data sets, and it's going to give you a much more balanced data. If you do not unlink the chain, you're going to have a very red image. So let's just unlink the chain, and then we're going to hit the little nuclear button. And sure enough, we have what looks to be a color balanced image. It's not, it just looks that way because we're allowed to see it that way. That's all it is. This is nothing permanent. Now that we've got it temporarily stretched so that we can see it, excuse me, what we want to do next is crop the image. And what I mean by crop is we want to cut some of the edges off, because on this data set, and I'm going to really stretch this, it'll scare you to look at it when it's really stretched. But if you look at the edge, you can see that there are some artifacts on there. And these are what we call stacking artifacts. And that's when you take all the different images that you take in the run of a night, 2 nights, 3 nights. And as your camera moves around, it could be due to dithering, where you're getting it to move purposely for each frame to mitigate noise. Or it could be just simply due that maybe one night the camera wasn't quite in the same spot it was the next night when you shot again. So you will get these artifacts. And they're usually right on the edges. Let me just open this up a little bit so I can show you the edge a little better. Oh, there we go. So we get right into the edge here. You can see there's lines going down. I'm not sure how well that's coming across on your computer. See that dark line that's on the top? That's all stuff we want to get rid of, because on our next step, after we do this cropping, we're going to do a background extraction, and the sample points that the background extraction tool creates will drop right at the very edges. If it's sitting on these artifacts, it's giving less than desirable data. So we want to get rid of those artifacts. So we're going to go ahead and do that. And how you do that is very, very simple. You simply go to the dynamic crop tool. And again, if you want to take it from here, again, all in alphabetical processes, all processes, and right down to where it says dynamic crop, that's where you find it. Or you can set it in your workflow. So there's your dynamic crop tool. Excuse me. Just click on your image, click on the tool, and now it's dynamic, it's ready to go. So all we want to do is just bring that in a little bit, because we want to take care of those edges that we know will be undesirable. And as we get further into processing, they will rear their little ugly heads, and we don't want to see them.
Yeah,
So
really, it's almost like sticking a whole bunch of photos on top of one another. That's all what we're doing, obviously, with stacking. But when you do that, any little shift this is what's happening, right? That's why you get those edges.
That's correct.
Yeah.
That's correct. Yeah. Yeah. It's like if you had one picture taken and the stars were tilted one way, and then you had to put another piece of paper over top, and you had to tilt that paper another way for them all to line up, then the edges of the paper don't line up anymore. And that's exactly what happens with these stacking artifacts. So I think I'm going to cut that edge off. I think that should be good. So let's go ahead and hit our little check mark. And now we're cropped. That's perfect.
Yep.
So
that's also something like when we were choosing the targets, we kept that in mind. So one of these, I can't remember which globular cluster it is, has a gorgeous little galaxy off to the side. It's a little red one.
Mhm.
So we were going to take it so that the globular cluster wouldn't have been centered in the image, and then we could capture that galaxy. And then I was looking at it, I'm like, I think that might be cut off like in our stacking artifacts, like this is, or like the stacking, like if it's right on the edge of the image, it's like,
Yeah,
I know that that's probably not going to make it. So I
yeah.
guess like when people are talking about framing and like how to catch, the
Well, that's
image
a really
well.
good point that you bring up, because when you look at the two, I call them shoulder stars.
Mhm.
It's not the right term, but this star right here is in exactly that position that you're talking about.
Yeah.
And so there are parts of this, and I took very little, but even if I didn't touch it at all, part of the star spike is
Mhm.
on the edge. And if there was more artifacts that we had to take away, then we would have lost that star. It would have been better just to cut the star out altogether than
Yeah.
only have a part of it there.
Yeah.
And which is the same as what you're talking about for that galaxy.
Yeah. Actually, I think it was M13 because when we were choosing it, I said, I'd rather have the galaxy in the center. And I do kind of like the little yellow and blue star off to the side. And then I didn't quite realize just how close that yellow star was to the edge.
Yeah.
It really is a little getting chopped off there.
But you know what? It's fine, because you can actually, and I looked at it, and when I looked at a finished one, I actually zoomed in. I just took the yellow star out, and I left the blue in there, and it still works out very nicely. So yeah. So there's always a way to crop it to make it look good.
Yep.
So there's our dynamic crop. So that's done. So we can put that tool away now. Actually, you know what? I'm going to leave it out because I'm going to do that with another image in a moment. Okay, so once we've got that done, then the next thing we want to do is we want to neutralize our background. And so we're going to do what's called DBE, which is dynamic background extraction. Again, all processes, alphabetical order, dynamic background extraction. That's where you would find it. So all we do is simply is open it up. Oh, I have another tool on. That's why. I will have to turn this off, but I'm going to save a copy of it. There we go. There. Because I saved that copy, when I make another image, I can just throw that on it and it will crop it exactly to this one. So they'll line up when I put them together.
Okay.
So I'm going to call that crop so I don't forget what it is, because I got a messy desk going on right now. So you go to your identifier, set your identifier, set icon identifier. First day, my new tongue. And I'm just going to call this crop so we know what that is. And I'm going to say okay. So now I know what that's for. Okay. So now we're going to do our dynamic background extraction. So you notice that when I clicked on this, we heard a little ding ding. It was a warning. Yep. With PixInsight, you can't have two dynamic tools open at the same time.
Oh, okay.
So that's why you hear that little warning. Now we shouldn't have any trouble opening. There it is.
Mm-hmm.
So there's our background extraction. And this tool, what it's designed to do is to take away any kind of gradients that we would have. If there's some vignetting on there, any kind of these unequal areas in our image in the background, that's its job to take care of it. So this actually, as complicated as it looks, is a really simple tool.
Yeah.
We're going to go down to sample generation first, because this is where we're going to create our sample points. Sample points are designed to pick up the background. So we don't want them over bright stars. We certainly don't want them on the cluster, which is a bunch of bright stars. And we don't want them on any part of a nebula if we're actually doing a nebula rather than a cluster. So I like to use about the size 75 for my samples, because the larger the sample, if I do happen to have a small star on it, then the least effect it will have on that sample point. So, and 3 is plenty for this particular thing. So all we got to do now is simply hit generate, and it's generated our sample points. So these sample points, you can see one is on a star already. Any one of that is green is actually reflected in this window.
Okay.
So if I put that right down here, you can see that I'm right in the middle of the cluster, right? It's not even going to register, because that's a ridiculous point. You're going to be kidding me. So right about,
just when you think, there's another star popping up, like this is,
I'll put this one here. And what I'm looking for, if I can find a spot that there's no stars, but it's in proximity to where these points are, then that's where I'm going to put it. So you can see there, that little tiny star is so insignificant in that size of that sample box that it's not going to hurt our ability to.
Okay, so a little star is not
A little star is okay.
Okay.
Unless our sample box is really small, because it's a percentage, right? It's a percentage of light that's in that box.
Right.
And if it's just a tiny percentage, then that percentage will not be affected. But if I shrunk that box down and that star seemed quite big, then absolutely I would have to find a place that there is no stars. So that's why the larger box I choose. Okay.
Gotcha.
So there.
Yeah, I use primarily Photoshop just because my computer is very weak and it doesn't have a lot of power. And I've found that I started using RC Astro Gradient Exterminator.
Perfect.
And yeah, so this tool I think does exactly what you're doing, except probably like it's relatively powerful, and I'm still trying to learn how to use it. Like you can create separate, but it's a couple extra steps. And so this is where PixInsight, like if you're doing a lot of astrophotography, and we discussed this I think last time, when you're doing a lot, it's like PixInsight cuts down the steps, and so it's like, how much is your time worth to you? Like,
exactly.
Get PixInsight and it costs a few extra bucks, but it's also like takes a lot less time than.
Yeah, once you understand it's like anything, like even with like Photoshop.
Yeah,
that's where I started as well.
Yeah,
and that RC Astro is called Gradient Exterminator.
Yeah,
and that thing works beautifully. And in fact, I'm going to show you a new tool from RC Astro on this stuff for tonight.
Great.
It's made for PixInsight, but soon will be available for Photoshop.
Okay.
And it's going to save it makes it even faster for what we're doing here.
Awesome.
I'm real excited about it, and I think you will be too when you see it.
Yeah.
Okay, so I'm going to get rid of these 4 stars in the center because this is high star area. So I don't want those at all. So you can just simply click on it. When it's green, it's the one that's in play, and you can just simply delete it with that little red box up in the corner. So let's get rid of those points. We don't want them. They are too close to a star-rich area. So I'm just going to work on the outskirts for this particular one. There. So all of those sample points are in place. It looks pretty good to me. Before I go any further, I'm going to drag and drop this tool because I'm going to have to use this tool a couple of times. And rather than having to set up these points again, all I have to do is turn this on and these points will automatically be there for me. Okay, so the first thing we want to do, a lot of people, there's 2 things you're going to do with this. Once you get your sample points on, you can close that up. The only other thing you're going to use is target image correction, which is this little drop down right here. Now, what we want to do is select whether we're going to do subtraction or division. I always do both. A lot of the more wiser than me people in PixInsight choose division first. So let's do that. So we just simply click on division. We've already got our sample points in play. All we're going to do now is simply drag the little triangle and drop it on the picture. It's going to create 2 images. One's going to be our background model. So if I really was to stretch that image, this is what we're trying to do. We're trying to make a model of what it is that we're trying to mitigate. So you can see there's all kinds of funky things in that image that we need to correct. So this to me looks like the correct model for what we're trying to fix. So I'm okay with that. So I don't need that. So I'm going to toss that. This is the actual image after its first background extraction. So there it is. So it's already starting to look a little more even and nice. So once we've got that done, then we simply are going to close off the background extraction. I don't need that original image anymore. It's gone. Now I'm going to reopen that. Remember that one I dropped down? There's the same tool where there's the same points. The only thing I have to do now is my subtraction. Simply put on subtraction, take my little triangle, drag it and drop it on the image. And now I have done both forms of background extraction. Now, why 2 forms? Very simple. The subtraction is designed for gradients, and the division is designed for vignetting, and maybe there's some little dust, some inaccurate things. So they both actually do two different things. And that's why I always apply both, because then if there is both one or both of them there, it'll always be corrected. So there's my background model. I'm not even going to bother looking at it because I know it worked great on the first one. And now I'm going to turn off the background extraction. Don't need it anymore. Get rid of that image. And now we have our image that has been subtracted and divided. And now we have a nice looking image so far. So far, so good. So the next thing we want to do is we want to neutralize that background. So very simple. You simply go to Process, All Processes, and we're looking for, I can never remember what they call it. It should be called background neutralization. There it is.
Exactly where it's
that's what they call it. So with background neutralization, what we need to do is we need to create a sample point on this image to what we think is a good spot. I worked this image enough, I know where that spot is. So, so what I'm going to do is I'm going to increase the size of the image, because my sample box that I'm going to put here cannot be on a star. It has to be a really, really good background. And I'm just looking for a spot that's even. If you look at the three numbers, the R, the G, and the B on that little window, I'm trying to make those as even as possible, because then that gives me a good representation of an equalization of red, green, and blue.
Right.
So if there, 29, 29, 31, that's close. That's close enough for me. So that's where I'm going to create my preview. So I'm just going to create my little preview box. It doesn't have to be big. It's very small, as you can see. But I've got that box created now. So that is my reference image for this to basically neutralize my background. So now I just have to find out, okay, I'm neutralizing on image 44 dBE, preview 1. So let's find it. Image 44 dBE, there it is, preview 1. So that's the one that is now in my reference image. All I do now is take that little triangle, drag and drop. It's done. My background has now been neutralized. So that was quite simple. If you want to unstretch it and restretch it again, it'll give you the actual neutralization. That's a nice even background so far. Okay, so now that we've got that done, the only other thing that we need to do with this image is to color calibrate it. Now, the color calibration is exactly the same process I went through with the neutralization. And what it's looking for white points, which basically it's going to use the stars, the small and the medium-sized stars in the image as a white reference. Same as when you're trying to color balance anything in Photoshop. You're looking for a white reference because you want to neutralize. So what it's trying to do is to give me the best possible gray background that it can, so that all the other colors that are in the image are correct. So that's its job. So let's take our reference image, which is still reference 1. I can still use that. So let's go to that same reference image. And that was called image 44 DVD 1. And we'll put him in there. Okay. We need not do anything else. I've gone over this book a number of times. Whoops, I put it in the wrong place. Sorry about that. Let me take that out. There we go. What I did is I put it in the white reference area, and I shouldn't have. Okay. With white reference, as we just talked about, the star detection is checked, and that's what we're using for white reference.
Okay.
That should have went down here. So I apologize for making that mistake and causing any confusion. There we go. So now that is background reference. Then that's where it should go. All the defaults work extremely well. So just like our tool before, grab that blue triangle, drag and drop. And there, it is done. So now we have our image up to this point is ready to be processed, except for noise reduction. Now, what I'm going to do before I do noise reduction is we talked earlier about the luminance, and I'm going to use the luminance on this because it's just, it will bring, how I'm going to stretch this out, you'll see why I will need that. So to create a luminance, a synthetic luminance, if you don't have one, it's quite simple. Just go to the little box on the top, and you're going to see where it says extract CIL, the L component, which is the lightness. I just click on that. And there is the exact image, but just the lightness. So now I have my luminance to work with.
So you created a luminance farm.
Yeah, and that's what we call a synthetic luminance, as opposed to a luminance that we would have taken separately.
Not gonna lie, I was wondering where you got the luminance when we didn't have luminance data collected.
Yeah, so you make your own. That's the beauty of it, and that's the beauty of PixInsight. It makes that process so simple. A push of a button.
It's effective that I've got this space image behind me because.
Okay, so we've got that. So now I can go ahead and now we're going to introduce that new product from RASC Astro. Now, normally our next step to take care of our noise on this, we would use multi-level transfer, multi-scale linear transfer. And that one would require making a mask. Then it would require setting all of our parameters and doing all kinds of different things to get it ready to reduce the noise. And then we'd have to experiment with it. Well, guess what? We have a new tool from RASC Astro, and it's called, guess what? Noise Exterminator. And there it is. That little thing right there is absolutely amazing. And I want to show you how well it works. Let's go ahead and take a preview, because we want to get in nice and tight on this, because I really want to show you this. This is so exciting. So let's open up our preview. So there's our preview. The reason I'm using a preview is because I can make the tool perform much quicker on a smaller portion of the image to see how the tool is working. This tool has only two settings. It's either denoise, which is taking care of the noise, and detail. How much detail do we want to put back into the image prior to it starting to give us those black rings around the stars, and which is called de-ringing, which is a whole other process we have to set up for in the other tool. Well, guess what? This one does that for us too. This is beautiful. So this one here, you'll notice on the bottom, it's got a little check mark where it says linear. Yeah. So that means I can use this tool in linear form, which is where we still are, or if after I've stretched it and then it's non-linear, I can use it in that form as well. So if I'm using a non-linear on it, I'll just make sure that box is not checked. If I'm using it as linear, I want to make sure that I'm using it in linear. Otherwise, you'll see some funky things. You'll say, oh my God, what did I do? And you just said, come on, man. Do the right thing. Okay, so let's go ahead and let's look at the noise. So you can see lots of noise, right?
Oh, yeah.
All right. So
I noticed that when I was playing around with it, there was quite a bit of noise, but that's expected.
And that's normal for every image. So let's go ahead and apply our noise reduction to this image.
That little RC pop is very classy.
Yeah.
Like, down, it just shot an RC back at you. But
let's look at that.
Wow.
Look at before, after.
Oh, that's.
And look, and what did I have to do? Push a button.
Yeah.
I'm so excited. The one thing you'll find about noise reduction and being able to use it properly, and the time that it takes to learn to use it properly, is it can degrade the quality of your image if you apply too much noise reduction.
Yeah.
But let's have a look at our stars in the glob part of this image right here. So let's look at it before noise reduction and after. It has not affected our stars whatsoever.
No, it really didn't.
Yeah, but it's taken away all the noise and given us a nice, smooth image to work with, all at the press of a button. Thank you, RASC Astro, for this wonderful tool.
How does it know?
Yeah, Well, he uses the AI technology. This is way beyond, anybody that I know, because this is programmer stuff, but he's done such an amazing job with it. Same as he has that gradient exterminator that you spoke of. And he's also the guy that does the star exterminator.
Okay, gotcha.
Yeah. And this guy's an astrophotographer too, right?
Yeah.
So it's just unbelievable, this tool that he's created. So this is the latest thing, all the latest astronomy editing YouTube videos. A whole bunch of them now are addressing this, and they're all excited about it. Even the masters of PixInsight are incorporating it into their workflow. So yeah, so it's very exciting. So once you're happy with the results, remember to put it to the image, because that was just on the preview. So let's go to our whole image and let's apply that noise reduction to that image. And again, it's super, super fast. It won't take any time at all. Just time enough to take a little sip of your coffee. Enjoy it. Savor the flavor, as it were. And we're halfway through it already. And this is so simple. I'm so excited about this. And when this becomes available for Photoshop, I can't imagine anybody not wanting this to take care of noise.
Yep. And is it, I mean, I'm just asking out into the, I wonder how it'll get rid of noise in images that aren't necessarily astrophotography too.
You know what? I would suspect yes. Again, I don't know how it's done, and I've certainly not tried it.
Yeah.
But you know what? Now that you've mentioned that, I'm going to take some of my wildlife pictures. I'm going to put them in here, and then I'm going to go ahead and see if I can't
play around with the tools. Yeah.
I'm going to try it.
Yeah.
Thank you for that. Yes.
Anytime.
Yeah, it'll be interesting to know how that will work. Okay, so once we've got that done, then realistically, I'm good with this.
Mm-hmm.
So the only thing I got to do now is just prepare my. Oh no, I got to stretch this. Sorry. Okay, so let's get rid of that. Let's take care of all of these previews now. We just want to clean it right up. Delete. Preview. Delete. Okay, so now we have our nice clean image and ready to go. So now this is where the rubber meets the road. This is the most important part of this whole process of working with this data, working with a globular cluster. It's how are we going to stretch this? There are 3 ways to do it. I'm not going to show you all 3, but I'm going to talk a little bit about them. The first way that we stretch any image, as we typically would, is we would take our STF function, and then we would turn our screen transfer function off. So it's like this. Then we would take our histogram transformation tool, and we would clear that off. And then all we would do is we would go here and we would stretch the image. And there it is stretched. The first thing you're going to notice is that center, if you take your mouse cursor, thank you, and you put it anywhere on there, and you're going to get some things that are really, really close to being blown out. That's already beyond what we can do to try to retrieve good color from that image. It looks impressive, and a lot of times when you see globular clusters, you'll see them with practically no color in them. And this is the reason why. It's because they weren't stretched with care. Because these ones really need to be stretched with care. So we're not going to do it this way. So we're just going to go ahead and take that and turn that stretch off. We don't want that. We're not going to use this tool for this particular session. There's another stretching format you can do called masked, M-A-S-K-E-D, mask stretch, or arc sine. Now, Photoshop has arc sine stretch in it. So that would be the tool if I was using Photoshop. Instead of just using curves and levels to stretch it out, I would use the arc sine stretch because it's a much more weighted way to stretch your image. So let's go ahead. PixInsight has arc sine stretch. All processes near the top, arc sine stretch right there. So here's the tool. Again, a very, very simple tool, but so effective and so important for this particular target. So So the stretch factor is how much we're going to stretch it. And the black point is how dark do we want our background. Now, according to my guru, Mr. Ron Breacher, he likes to have the backgrounds at about 10. That's where he likes to keep his backgrounds. They're not black, they're not gray, but they're in that spot that, you know, there is color, but it's neutral. And that's what he likes to keep it around. So that will be our background point that we want to be at. And we're going to show you how to do that. So what we do with our Sine Stretch, this one is, again, is another dynamic tool, and it's got the little circle, which means we can see a preview. So we're going to go ahead and create a preview. This is a real-time preview so that we can see exactly what it is that we're doing. So with this Sine Stretch, all we need to do is to go ahead and use our stretch factor, which is what's going to open up our brightness. So as you can see, I'm gingerly doing this, and our image is starting to come to life. But what's the first thing you notice compared to the other way we stretched it?
Well, I don't know if it's just the screen over here, but it's kind of doing this kind of weird cloudy thing. But I also see you're pulling color out.
Yeah.
You're getting
Look
a
at
lot
those
of
blue and yellow stars.
Yeah.
Right from the get-go, as opposed to something that was pretty much blown out before we did anything, right?
Yeah. Yeah.
So that's why I kind of wanted to point this one out.
Okay.
So yeah, so you're correct. We're pulling it out, but we're pulling it out slowly and not aggressively at all. So I like that so far. So rather than doing this doing this all in one shot, I'm going to do this. I might use 3 times to do this, but the same thing over and over. So it's really easy to do. If I want to protect my highlights, you can see that I can do that. I'm not going to be worried about that because I think I'm going to be okay with this.
And it's fairly early in the process right now too, right? So it's okay not to protect the highlights because we're not even, like if you looked at the histogram, most of your data would be in the kind of first darker half, right?
Exactly.
Yeah.
Exactly. Yeah, it will be so extreme left. It will look like we haven't done anything to it.
Yeah. Okay.
So let's go ahead and look at our black point. So what we do with, again, the tool that we use, if you look on the top of your screen, I'll lay it over there and it should tell us what it is. Maybe it won't. If I click on it, maybe. There we go. It's called readout mode. And what that does, that reads out what the values are in our background.
Gotcha.
So right now, our values are 741, 741, 715. So to me, that's pleasing because first of all, I know it's an even background. Mm-hmm. And secondly, I'm kind of getting there. But if I want to bring my black point up, whoops, did too much. And I'll use this one because it'll go a little more gentle for me.
Oh, look at that. Okay. I see.
So now, whoops. So if I can do it there, or I might even bring this up this way a little bit more.
Right.
Yeah, there. I'm at 10.55, 10.19. So I'm pretty much at 10. I'm where I should be as far as Mr. Breacher was concerned. So if that's the case, again, this is just my real-time preview. I want to apply this to here. So all I have to do is hit the square and it will apply it to the image for me. It's going to overstretch this one because it applied it to this again. So I just reset the tool.
Gotcha. Okay.
Okay. So there was my first stretch. So I think we can agree that this stretch looks pretty darn good.
Yeah, it does.
Let me just go ahead. The neat thing about this, whoops, let me go back to where I was. The neat thing about this tool too, this preview, I want to show those who maybe are using this and may not be aware of this, because they keep thinking, well, I get a preview, but I can't make it big enough to see what I need to see. Well, if you go down here, there's this little box that you check. You simply click on it, and you can actually put a box around, say, the blob, let it go, and it brings it right in for you.
Yeah.
So you can see exactly what you're doing, even on the preview. But I'm quite pleased with this. I think this looks terrific. I'm not sure if I need to stretch it anymore at all. So, but just for fun, let's do it. Make sure I don't overdo it. So we go ahead, and now that we've got our thing done, if I want to bring it out even more, but you can see it's now getting to a point where
you're basically just moving
the player really ginger, right?
Yeah.
There, And then let's go ahead and can I bring my black point down? There we go. Let's look at it. 11, so I can come down a little bit more. Close enough to 10 for me. So that looks good. I'm happy with that. So I'm just going to apply it. Ta-da. And we are done. There is our stretched image. We are now in nonlinear mode. Now, like you said earlier, if you don't want to apply luminance to this, you don't have to. You can make it bright enough if you want to. But let's just say I wanted to apply luminance to it. Then the only thing I'd have to do is that luminance that I took, and where did I put it? Oh my God.
Image 44, is that the one?
And it's 44, there it is.
There it is.
And the good thing you're with me here tonight, Linda.
Yeah.
I mean, it's like making this big supper, and then you've got everything all over the table and you can't find anything anymore.
Yeah. That's the carrots. Where are the carrots? They're
Where are
under
the carrots.
Like, yeah.
So anyway, so here's our image. So the only thing I need to do with this is add our, I'm just going to shrink that down for a minute. Image 44. We're just going to add our noise reduction. So we'll go ahead to that nice new product called Noise Exterminator. And whoops, one button too many. And let's just go ahead and do the same thing. Just drop it on. It'll take no time at all. Oh, it's just so easy. Oh my goodness, I can't believe how simple this is. It's such a nice treat to be able to find a tool that works very effective and have to do fewer steps. Because let's face it, we don't want to spend our lives processing a picture.
No.
However, it's a good way to spend time.
But this saves the time. So you can go out and collect more data. And then
That's right. And this is it. This is the beauty of this. 95, there we go, done. So that's very simple. So now I'm going to do the same thing that I just did with the last image. So I'm going to turn the stretch off. I'm going to go ahead and process. I'm going to stretch it with the same tool, Sine Stretch. Create my preview. Reset it. And go ahead and bring up my lightness. Just a little bit there. Good. Check my background. Still a little dark. So I'll bring it up a little bit more. Check my background. Close enough for me, and girl, I see. So I will maybe just a little brighter. Yeah, that's close enough to 10. 996 is pretty darn close. Okay. Oops.
read it.
Oh my goodness. All right, let's try that again.
At least it's, easy enough.
Yeah. Actually, I think it just came right back. Yeah, it did.
Oh,
So
perfect.
Yeah. So all I have to do is just apply it to the image. And I can press the square, or I can drag and drop, whichever I prefer. And if I don't think that that's bright enough, which I don't think it is, I think I need to go a little brighter yet. I'm going to go ahead and reset this. And I'm going to make that just a little brighter, because I don't think there's enough brightness on that one yet. There, that's better. And let's go ahead and make that a little darker in the background.
Yeah. So that almost functions a little bit like a contrast, hey?
Yeah. Yeah. So basically, it's black point and stretch really is what it is. Oh, that's perfect. Okay, so we're going to apply that before I turn it off this time. There we go. And so that's it. So now I've got a stretched luminance image. I'm going to now call this, go to my identifier, and I'm going to call it Lum, L-U-M. So that's how you create a synthetic luminance. Whoops.
There's a loom right above.
Yeah, so I'm going to call it Lum 1. There we go. So that's how you create a synthetic luminance if you don't have luminance data and you want to use some. Open up our image 44. Now, all we're going to do is go to our channel combination, LRGB combo. It's already pre-arranged with Lum in it, but I have to add Lum 1. Always make sure that this is exactly what you're trying to put in. You don't have to do anything else to this image. Just simply put in this data, drag and drop, and this should
okay.
Apply the luminance over top of this color data.
Drum roll.
Ta-da! It's done. Just that fast. So this is before, this is after. So it's really not enough. So let's go ahead and let's just stretch that a little bit more. It needs a little bit more stretching. It's not bright enough. It hasn't made enough difference for my liking. So let's go back to process, all processes. And I know this seems like a little long, but these are the things
this is how it goes. Yeah.
This is real life with this stuff. So
it's all finagling little details, right? It's
it is.
And like I do a lot of stretching of the but that's basically I use the curves tool in Photoshop, and I kind of pin 2 points and then pull it up, and I have to do it like 20 or 30 times, and eventually I get to a point that
you're
not
happy,
miserable.
Yeah. Exactly there. That's close enough. I think that looks good. So let's apply that. Okay, don't look at that one. That's just a preview. Okay, now let's apply this to that image again, and let's see what happens. Go back to our LRGB combo, add the number 1, and then let's drag and drop. Oh, did I take it off? Oh. If you have 2 images open, here's a tip. Make sure whichever one that you're trying to make an adjustment to is clicked on and it's blue.
Gotcha.
There, I want to take that first luminance off. Okay, so now we're going to go ahead and add the new luminance to and it won't take very long. Oh yeah, there we go. There we go.
There, it's brighter. Yeah.
Now it's come to life.
Yeah.
Okay. So now that we've got that done, that was basically the hardest part of the whole image, believe it or not. So now if you look at our image, the first thing we want to make sure is we haven't blown anything out, which we haven't.
You haven't, no.
I'm seeing some nice yellow and nice blue stars.
Yeah.
We will see, however, in those really, really bright stars, there's going to be some artifacts. We can fix that later. And you can do that in Photoshop, actually. It's pretty hard to do it in PixInsight, but I can do it in Photoshop quite easily. But we won't worry about that for now, because that's the only 2 spots on the whole image that have stars that are kind of funky, but that's okay. All right, so now that we've got that done, now we can go ahead. Now we are in non-linear mode. We have done everything we want to do to kind of clean the image up. So now what we want to do here is have a look at our data. And if we dig right into it, and that's so clean. I can't believe how clean that is. Let's go ahead and we can try and apply an SCNR. What this does, if there's any green cast left over, it will take it right out. So let's go ahead and apply it. And then let's look at our image now, see if there was much of a difference. A little close for that glob. I'll go back before. Yeah, not much, which means that the image was quite balanced. So I'm good with that. All right, so now that we've got that done, we want to do one more histogram transformation. Right here. And all I want to do here is just have a look at the image, make sure that
so you like the histogram?
Yeah, I want to make sure that all the colors are balanced. And if you look at this, they are.
Yeah.
Right?
Perfectly.
Perfectly. I mean, wow, right? So let's have a look at this. 65, 63, 61. That's so close. You know what I mean? That's close enough for hand grenades and what's the other thing? Horseshoes.
Horseshoes.
So yeah, I'm actually quite pleased with that. So I'm not even going to do anything with this. We're good. So the only thing that we might want to do from this stage really is to do some contrast. adjustments, which is very, very simple. You go to your local histogram equalization tool, and this is a contrast tool. Now, I do this twice, and I'm going to show you where. The first time I do it, my kernel radius is at 50. And I leave it there because this is I'm working on like a larger structure is what I'm doing here. So I'm going to do a contrast adjustment on a larger scale of things. I'm going to take that 2 and I'm going to pop it back to 1.5. And then my amount on this, I always set it to 40 because 40 seems to be the sweet spot for most images that I've done. And all this is a contrast adjustment. So we really shouldn't be seeing anything colossal, but we should be seeing a little bit more contrast to the image. It won't take long. It's a pretty fast moving tool. We're at 70% already. There we go.
And do I already see that little propeller?
You see it?
I think, is that where that mouse is?
Yep.
Yeah, there it is.
There it is. Oh, there it is.
Yeah.
Now we're going to do the same thing with a local histogram equalization. This time our kernel radius is going to be 150. We're going to leave it at 1.5 and this time at 30. That's the only difference. Go ahead and apply it. And again, we should see just, again, an ever so slight change in contrast. And we're at 70% already. Again, a very quick tool. And there we go. And again, I saw that nice adjustment in contrast. So if I go back before, see the difference?
Ever so slight, but
ever so slight. And in photo editing, everything that you do should be ever so slight.
Yep. Yep.
And I think, other than doing some color calibration, there's only one other step that I would do to this image. And I think we should do it because we talked earlier about that banding that we had.
Yeah.
Here.
Yeah.
We want to mitigate that. So there's the way to do that is quite simple. The first thing we need to do is remove the stars from the image. So I'm going to go all processes.
Oh, that's a lot of stars.
Yeah, and there's a lot of stars to take off. So we're going to go to Star Exterminator, which is the other RC Astro tool. We're really using their tools tonight. We want to generate a star image because we want to have the stars to put back, right? But this is non-linear because we've already stretched this. So we're not going to check the linear box. And like all RC Astro tools, drag and drop. This one will chew through. This won't take maybe a minute or two to do. But the reason I'm doing this is because I'm creating an image which is going to be starless, and I'm going to have my stars separate. And then I'm going to take my stars and I'm going to just simply do that same lightness to create my star mask as we took, remember when we did the lightness off the RGB image to create the luminance, simply push of a button. And that's how simple this is. So this is the longest part of waiting for the stars to come off. We're already at 35%, so it won't take too long. But this is going to be the part where of the process where we're going to add color to the stars, do a little star shaping, and we're going to clean up that background. And then that's pretty much it. The image will be complete.
And so this is it similar to what you did in our last session with the star, making those soft stars? Yes,
I'm going to try to make these ones soft. These ones, well, we'll see how it goes.
They're rather important points in some of these stars. Like they're a little less soft than our last image, I think. Yeah, especially in this particular target, because the target is all stars. And we need to have those stars pop at us. We need to have some definition in each one of the stars. So if I'm too soft with it, it'll look like mush. Right. So there, we've got our stars taken off. So there they are. So before I put them away, I'm going to, now that it's blue, again, because that's the one I want to do a thing on, I'm going to create our star mask. So I'm just going to click that button. There it is. So there's our star mask there. So this is our background. This is the image without stars, which is basically nothing. Really, other than the star spikes off those two bright stars. But that thing right there is what I want to get rid of. Right.
So first of all, what I want to do is I want to maybe just take that background down just a little tiny bit. So I'm going to, I'm starting to get really busy here on the screen. So I'm going to take this image 44 and put it down here, and this one right on top of it, and we'll, so that we know where they are. All right, so this one here, I'm going to go ahead and open up our curves. And all I want to do is go to, and we can create a preview, on a real-time preview. And I'm just going to go to my lightness on this one. And I'm just going to just slightly darken. Just a bit. Because to me, that kind of evens out a little bit more. Still giving us, 9 in that range. I'm okay with that. Once I've got that done, I'm going to apply it to the image. Okay, so now I don't need the curves for the time being. We'll get rid of that. So we've applied that to this image. And now I'm going to take my clone stamp tool. So we're going to go to processes, all processes, and we're going to go to clone stamp.
There it is.
There's clone stamp. There it is. So again, with this one, you click on the image, click on the little button, and it comes to life. So my radius right now is 100. That's probably too aggressive. I'm going to take, or too big. I'm going to take that down to 75. That's the size of the brush I'm choosing. On this particular image, we've got a relatively light background, so I don't want to be aggressive with my opacity. If I'm too aggressive with my opacity, I'm going to see black streaks. What I want is a blend so that we don't see this thing, but I'm not seeing a difference in my background. So my opacity is only at 11, and my brush is at 70, which is really soft. So all we do is we go to our image, and we press the control button, click the button down, and that allows us to have this little string attached to it. So all we're going to do here is just, I'm going to get a little closer to it. There we go. And you can see now how gently that's taking that away. I mean, I could spend more time on this and make it perfect, but I just want to show you the technique. And that line, and I want to even this off. Oops. Just want to get rid of that line in between there. So that's all we're doing, is we're just basically painting over with a very, very gentle amount of opacity. Just enough to make it everything smooth, but not in your face. Because by the time we get everything else back into this, you won't see that. Okay, if I'm happy with that adjustment, then I'll just go ahead and push my little green check mark. It makes the adjustment. I can close the tool. Now my background is pretty much where I want it to be. I'm pretty pleased with that. So if I'm pleased with that, again, you can see that mark there. I mean, I would be a lot more, but you don't want to sit here and watch me do that.
No.
So now all I have to do is I want to put my stars back on. Very simple procedure. Simply go to processes, all processes, go down to pixel math. People get scared when they say pixel math. I know I was scared when I first saw it, but now that I understand it to a degree, it's really quite simple to use. So what I want to do is I want to go to my expression editor. Okay, here I want to basically take this off. I want to clear that off. And this is image 44 dBE dBE. I'm going to find that here. Image 44 dBE dBE, double click it, and it appears in my Dropbox. All I'm going to do now is simply hit the add the plus key, because I want to add the stars, and I need my image 44 dBE dBE stars. So there they are. Double click on it, and sure enough, they're in the box. Simply hit OK, drag and drop, and my stars magically get back on the image.
Oh, there we go. Perfect.
Just like that.
Yeah.
And now when we look at that background, that again, we know that I made a little foober here, but at least that big blue bright spot is gone.
Yeah.
So that's, but if I took my time with it, I could really make it clean.
Yeah, of course. It makes sense. Like it's you've shown us the tool. Now it's up to everybody else to
We're going to go. No, really, and that's the only way to do it, is to work on it and learn it. Really. Okay, so the only other thing we need to do now is we want to add, remember we took that lightness off of our stars?
Mask.
That's going to act as our star mask.
Okay.
Simply drag it and drop it over there.
Ah.
And now you can see,
The mask.
yeah, if I do it, if I invert it, anything that's red is protected. I'm protecting the stars working on the background. That's not what I want to do. I want to do the opposite. So I want to invert that so that I'm protecting the background, but I'm working on the stars.
Yep.
Once I've got that selected, there's a button right over here that will allow you to hide the mask. We know that if it's brown over here, the mask is still there, but we can see that we can work, right?
Yep.
So let's go ahead now and let's add a little color, a little pop to those stars. Go to our curves transformation tool, and then we're going to simply do our preview, our real live preview. And I want to see those stars. So I'm going to go ahead and create a preview of the preview so that I'm not getting overly zealous with my saturation. Mm-hmm. We're going to go to our curves tool, go to our saturation, and then we can go ahead and start adding a little pop. And sure enough, there it is. Look. That is gorgeous. So now we've got all these lovely blue stars, all these lovely yellow stars. If we want a little less aggressiveness on the blue stars, go ahead here to this little one called the CIEB component. Mm-hmm. If I push it, I will actually reduce blue. If I pull it, I will increase blue. So let's push it a little bit. And there, that's a little,
wow, there it is. Yeah.
That's a little better balance, right?
Yeah.
I think that looks good. I'm actually pleased with that. So let's go ahead and apply this curves adjustment. And pretty darn good.
Yeah.
And if at the end of it, I want to shrink the stars because that mask is still on, and I just want to tighten them up a little bit, I'm just going to go ahead and get rid of curves because we've applied it. Then I'm just going to open up my morphological transformation tool, and I'm going to use a preview again, and we're just going to go ahead and see if we can tighten those stars up just a little bit. So by doing that, we can do it from morphological selection. Yeah. We can use, I set it up for 86 on amount, 40 on selection, just drag and drop. And let's see if it does anything for us. And it just softens them a little bit. Yeah. It might take some of those funny edges off. Yeah. Or if you don't want to soften them, you don't have to. It's really, at this point, it's salt and pepper, like we talked before.
Yeah. A little bit of extra flavor.
Yeah, I kind of like that. So that looks good to me. So let's just go ahead and apply it. And then I'm going to do one final thing to it, which is sharpening, which will give us back that definition. And then the image is complete. So we're just going to remove that. And then we're going to go ahead, remove this. And I'm going to get my mask, remove the mask. Final process, all processes, unsharpened mask. We'll try default settings and see how that works. And let's look at our preview and the center so we can see the stars. There they are. They actually look pretty darn good. And we can go ahead and apply it. And if we like it, we'll keep it. Oh yeah, that opened them. Yeah, love it. So let's go ahead and apply that to the image. Oh yeah.
There you go.
Did it ever make that?
It really, yeah, that makes it pop.
It brought it right to life, didn't it?
Yeah.
Wow. Anyway, again.
And I like this to me is like when you look at a globular cluster through a telescope, like it looks like little pinpricks. It's like really faint and fuzzy, right?
Yes.
And so there are a lot of beautiful images out there, but it's not necessarily what you see through a telescope. And so to me, this looks a little bit more like what I'm going to see. And I like that. I like that a lot. Like it seems personally a little true to life.
Yeah, no, absolutely. Yeah, absolutely. It's this data, at first glance, you say, oh, no, but when you like any other data set, yeah. Once you get into it, it's like, oh my gosh, this is actually quite beautiful. Yeah. If I just increase the size of this, just so you can,
yeah, please
look at that. I mean, that's stunning.
Yeah.
Right. We could fix those two stars, like I said, but we don't. I'm not even concerned about them at this stage.
Yeah.
There's your color right there, and look at the look at that little rainfall of stars. Right
Yeah.
here. It's just so much. It's just such. Once you complete this, turn your lights off, make it as big as you can, sit back and look at it because it's just so gorgeous.
It definitely is. What was it? A blizzarding metropolis of stars, hundreds of thousands ish.
Oh my gosh. It's such a beautiful, beautiful target.
Yeah, it is.
Anyway, so hopefully for those who get to look at this video, take your time when you're processing, but when you're doing globular clusters, I didn't spend hardly any time at all on the back end. In other words, when it's after it got stretched to the point, once I got that luminance added to it and it started to pop a little bit, it was just really a matter of salt and pepper, adding color and doing a few things, but getting that stretch right so that you're not blowing anything out, you're keeping your color integrity in it. It just makes all the difference in the world. It really does on these particular targets anyway.
Yeah. Oh, it's beautiful. You did a great job. I love this image.
Yeah, it turned out great. And I haven't done M3 yet, so I am going to do it. Just to see
that is there.
Yeah, just to see how it turns out.
Great. Well, thanks, Paul.
Yeah.
For teaching us how to edit astro images. This is, I didn't mention it at the beginning, but this is our last session, eh? So yeah. Well, it's been a slice. I've learned so much more about astro image editing than I walked in here with. And so it's wonderful. Thank you so much.
Oh, it's my pleasure.
Thank you.
Yeah, and I just like to say thank you for giving me the opportunity, and anybody out there that has I hope somebody's gotten something from this and learned some things, and because really that's what this was all about, was to share and teach and let you know that there's some data there. Thank you to SkyNews for supplying this data for everybody and for that contest. And again, I can't say enough about Sky News magazine, not because I've gotten to know Allendria, which I'm so thankful for, but it just the magazine itself has gotten so much more direction where it's going, I feel, and there's so much more support for everybody in the Canadian the hobby, especially for a lot of the astrophotographers out there are getting opportunities to show some of their images. And again, I just want to say thank you for that.
Hey, Sky News is a pleasure. It's it's what we're there for. So
absolutely.
Yeah. Well, thank you so much. It's been wonderful. I have gotten a lot of commentary from people who are very appreciative of all of the lessons that you've done with us and the positivity and it's all the small little victories. Is that what you say? Small victories.
Little victories, exactly.
Yeah.
I'm trying to find the button. Oh, here we are.
Yeah.
There.
Yeah.
I was still sharing.
Yeah. Well, it's a beautiful image to look at. Yeah. It to me, seeing that process too. It's maybe I don't have PixInsight. Maybe I'm not the best astro image editor in the world, but to see the process and how you get that data and how you pull it out, like that is like, it gives something extra to the picture. Like it's when you watch how the sausage is made, it's not always like, but it's, in this case, it's like I've learned something more about almost I would say almost about the astronomy behind it too, right? Like you can see all of those little blue stars, and they're there, like they're impossible to ignore.
Absolutely. Yeah.
So
yeah.
Really, thank you so much for teaching us.
Oh, my pleasure. Thank you. It's and again, it's been fun, and I have new equipment.
Yeah. Not a camera.
So thank you for that.
Yeah. And thank you to everybody who watches.
Absolutely.
We will be keeping this up on YouTube. And so anybody can come back. And if you ever have any questions, I would suggest sending an email to editor@skynews.ca, and we'll be there to respond. All right, great. Well, that's all I've got. Any final words or yeah?
No, that's good. Again, I just want to thank you for everything, and we did that, and it's been my pleasure to help.
Great. Well, and where can people watch you on the show?
The Sunday night astronomy show. Yes.
You want some more Paul Owen?
Yeah, and you can watch us there every Sunday night, 8 o'clock, and there's myself, Chris Kerwin, and Mike Powell. We just get together, talk anything and everything astronomy. We talk about imaging, we talk about gear, we talk about current events, we talk about space exploration. We cover it all. So yeah, Sunday nights, 8 o'clock, Sunday night astronomy show. And we're on Rogers now.
On Rogers?
Yeah.
Oh, really?
Yeah.
Making it big.
Yeah, well, we're just having fun.
That's awesome. All right. Well, again, thank you. And yeah, check out the Sunday night astronomy show, and happy photo editing.
Great.
Bye.
Thanks, everybody. Good night.